Here's the second video on solving systems by graphing. Now, we've already said that a system of linear equations is simply two or more equations working together. We also said that a solution to a system is that answer that works for both equations of the system. Graphically, it's the point of intersection, okay? So the next vocab words, consistent, inconsistent, dependent, and independent. Well, let's first look at the wall on the left side over there. You're going to see this picture. And if we take a look at this picture, a system is either going to be consistent or inconsistent, okay? So on the wall it says consistent systems. Now, what does consistent mean? Consistent means that it has answers. Has answers, all right? Inconsistent means that it has no answers, okay? So there is no solution to an inconsistent system. All right, now, if it's consistent, you might have one single answer, because remember, the line represents all of your solutions. The other line represents all your other solutions. So that single point of intersection is the only point in common, and that would be the solution to your system. But you might have a situation where you graph one line in black and you get this line, and then you graph the other line, the other equation in red, and you end up with the same exact equation. That's when the equations line up, you get the same exact line, which means that there's an infinite amount of answers that are in common, not one single answer in common over here. So I really need you guys to pay attention. This is going to be on the next quiz. You need to understand that consistent means it has answers or an answer. Inconsistent means it has no answers, which means that if you're looking for the point of intersection, they don't intersect because they're parallel. But over here, consistent, it might have one answer or it might have an infinite amount of answers. Now, let's think about some English vocabulary here. If I say you are financially independent of your parents, what does that mean? Financially independent. You live on your own, you pay your own bills, you feed yourself. Now, if you're financially dependent on your parents, what does that mean? Financially, you live with your parents, they pay for rent, they pay for food, everything, right? So it's the same concept here when you think of consistent independent and consistent dependent. Over here, dependent. So we need to understand the word independent and dependent. Independent means you're on your own. In other words, when you're talking about a consistent independent system, independent means one. That means that there really is one point in common, one solution to the whole system. Now, consistent dependent, that's when, like if you're dependent on your parents, they're carrying your weight. It's kind of like if you graph one line in black and you graph the other equation in red, and it ends up being the same exact line. So they're right on top of each other. So when I say how many points are in common in the red line and the black line, well, there's an infinite amount of answers. So consistent dependent is the classification for a system that has an infinite amount of answers. So this is all on the wall, and I put this on the wall so you could have a better understanding, an easier way of classifying systems. Inconsistent means it has no answer. So let's take a look back at our notes. Now, we're not going to actually write down the definition right here because it's already written down for us. Down here, what does consistent mean? Consistent means that it has an answer or many answers, right? It has a solution or solutions, many answers. They do exist. If you were to graph both equations, the lines will have a point in common. They might have one point in common, one single answer, if it's independent, or they might have an infinite amount of answers if the lines are the same, because you have an infinite amount of points in common. That's where you would call it a consistent dependent. Once again, the picture on the wall. These have answers. A consistent independent has one single answer. They intersect at this point. Consistent dependent is when you graph both lines and you realize it's the same line, which means that there's an infinite amount of that's in common, this is in common, that's in common. All the points are in common. So there's an infinite amount of answers that work. Okay, so this is just for the classifying part. We're going to have to actually solve. It might be a good idea on this next section to solve and then classify. So let's take a look at the tip up here before we even get into this. It says sometimes you don't even have to graph. If you're rewriting an equation in y equals mx plus b form, and you notice that only the m's are the same, you can conclude that they're parallel, which means that they don't cross, which means that you're not going to have a solution to that system. That means that they're inconsistent. But if you're rewriting it in slope-intercept form and you realize that you have the identical equation, everything's the same. You have the same slope, you have the same y-intercept, you're going to end up with the same line. So if you have the same line, how many points do those lines have in common? All the points are in common. So it's the same line, which means that all the points are in common, which means that the system has an infinite amount of solutions, which we could classify as consistent dependent. So let's take a look at this first one, ladies and gentlemen. If you have different colored pens, right now is the time to pull them out. If we take a look at this top one, I want to graph it in red. What is my slope? What's my y-intercept? My y-intercept is what? -2. So it's going to cross at the y-axis at -2, and from that point, I want to have the slope -3, which means down 3 over 1. So let me go to my graph. It crosses at -2 right here, and from this point, I want to go down 1, 2, 3, and over 1. Does that make sense? Yes. Okay, so my b value is -2, my m value is -3. Here's the -2, my b value. Then I go down 1, 2, 3, over 1. There's my line. Now, if my line is too small, which it is, you might want to use the same pattern of the slope of down 3 over 1, but backwards. Over 1, up 3, over 1, up 3. So you can make the line as long as you need to make it. Cool? Okay, now, at this point, let's graph the other line. Now, the other line, the other equation, it's not in slope-intercept form, so let me rewrite it. Let me rewrite this one in blue. I need to get y by itself. I'm going to subtract 2x. Subtract 2x. I'm going to have 3y equals -2x minus 6. And my final step would be to divide by 3, divide by 3, and divide by 3, which means I'll get y equals -2/3 x minus 2. Is everybody with me? So this bottom equation, all I did was rewrite it in slope-intercept form, and now it's easy to graph. Now what I'm going to do is I'm going to graph this guy. Where do I graph it? Well, it crosses at -2. So we already know that it's going to cross at -2 at that same exact value. So I'm going to put a blue dot right there. Now from that point, what do? I go down 2 over 3 based off of my slope. So I'm going to go down 2 over 1, 2, 3, and I'm going to put a blue dot right here. Now, of course, if you want to make this line longer the other way, just go with the pattern the other way. 1, 2, 3, and up 2. If you went down 2 over 3, go over 3, up 2. Over 3, up 2. And of course, if you connect the dots, you will see that it's a perfectly straight line. So, the top equation is in red. The bottom equation is in blue. Now, the red line represents every single answer that exists to that top equation. Once again, the red line represents all the answers that exist to this top equation. The blue line represents all the answers that exist to the bottom equation. So this is a system right here, guys. This is a system, and you want to find the answer that works for the entire system for both. So what is the answer that works for both? The coordinate that is shared by both. This point of intersection is the coordinate what? 0, -2. So what we're saying is that the answer is 0, -2. My x value is 0, my y value is -2. Are you absolutely positive that this is correct? Not yet. But what you could do is plug it in to make sure it actually works. So 0, -2. If you say x is 0 and y is -2, let's see if it really does give us the correct answer. If I were to plug in a negative 2 right here for y, and over here I'd have negative 3 times 0 for x minus 2, would that be a true statement right there? Would it be a true statement right there? Negative 2 equals, that cancels out, doesn't it? So negative 2 equals negative 2. Does it work? Yes, it does. It works for the top one. Now let's check the bottom one. Let's see if it works on the bottom one. Let's see if 0 for x. So plug in a 0 for x. It's going to be 2 times 0 plus 3 times y. 3 times negative 2 for y. Does it give you a negative 6? Yes, it does. So you've checked the top one. You've checked the bottom one. That's what we call double checking. So we're absolutely positive that 0 and 2, 0 for x, negative 2 for y, are the correct answers to this system. What do you guys think? So all we're doing is graphing and finding the point of intersection. By the way, if I asked you to classify this, if I asked you to classify it, well, first of all, is there an answer? Yes or no? Yes, there's an answer. So that means that it's consistent. Now, but there's two types of consistent, remember? There's consistent independent, which means there's only one answer, or consistent dependent, which is an infinite amount of answers. So if you were to classify it, you would say consistent what? Independent. That's ugly, but you know what I'm doing. Okay, let's try another. Let's graph the top one in red. Is it ready to graph? Is the top one ready to graph? No, of course not. You want to get y by itself first, right? Right. Okay, so what should I do? I'll first get rid of the minus 2x. Okay, let's get rid of that first, the minus 2x, by doing the opposite, plus 2x. What you do to one side, you do to the other side, plus 2x. You're going to have a new equation that says, let me write it over here on the side. It's going to say y equals positive 2x minus 3. This is my new slope-intercept form equation for that top equation. I know where it crosses my y-axis. I know the slope. Now the bottom equation in blue, it's already ready to graph. So let's graph the red and the blue lines. The red line crosses the y at negative 3. So it's going to cross right here at negative 3. And from that point, my slope is 2 over 1. So I need to go up 2 over 1 and put a dot right there. And I could keep going up 2 over 1, up 2 over 1, up 2 over 1. However long I need to go to make my line as long as I want it to be. So here's my line, my red one. Put some arrows on it. And now let's look at the blue one. Where does the blue one cross the y-axis? At positive 2, which is up here. And now from that point, what do? What's my slope? After you go positive 2, what's my slope? Down 3, 1, 2, 3, over 1. And guess what? We end up right here. So when we graph this guy, and you could keep going down 1, 2, 3, over 1 if you want. You could even go backwards, up 1. You could go backwards, up 3 over 1, up 3 over 1, up 1, 2, 3 over 1 to make it as long as you want. But here's my line. So the red line represents the top equation, the blue line represents the bottom equation, and remember, the line really does represent all the answers. This line represents all the answers of the bottom one. So we're looking for that single answer that works for both equations, and that would be the point of intersection. And what is that point of intersection, guys? That's positive 1, negative 1. Now you want to double check it. All you got to do is plug in a 1 for x and a negative 1 for y. Negative 2 times 1 is negative 2 plus a negative 1. That really does give me a negative 3. Or you could plug in the 1 in here for x and the negative 1 right here for y. And that would be negative 1 equals negative 3 times 1 plus 2. And of course that'll work also because you'll get negative 3 plus 2, which is negative 1. So it works for both. This answer right here works for both. You double checked it by plugging in to both equations in the system, and it works for both. So you're absolutely positive that the answer 1, negative 1 is your answer.